will do, once we have the starch, then we will identify that starch both chemically as well as microscopically.
Alpha, what? 2 chains, 1 4 linkages and 1 6 linkages.
Okay, so now what we are going to do, we are going to make a pulp out of it, pass it through it, do it fast.
So if you look at
add more
starch,
water.
In a wheat granule, starch will be arranged in the form of concentric circles. What is a concentric
Make sure
circle?
you put the hand,
You
it should
take
not,
a rope,
go ahead.
rope, you know what? You take a rope and coil it like this, one on another, like that. Alpha
Make
and
sure
beta
you put the hand,
amylose,
it should not,
chains will be
go ahead,
arranged
do it
with one another.
more.
Beautifully and compactly packed. Starch granules in rice is different from starch granules in wheat. Now he is going to isolate that. So isolate and give it in a pure form. I want you to divide, I don't know if possible, into 7 groups. I'll just tell you the names of experiments. Like after the experiment is over, we'll ask you like that.
Make sure you put the hand, it should not,
It's very easy to isolate. So he has selected phytochemical isolations which are very easy. Wheat. So another one is quinine from cinchona.
We are going to begin with the very first experiment, that is separation of starch from potato. Let me give some idea about the starch. Starch is extensively used in industry, whether it is food industry, pharmaceutical industry, or textile industry, or the paper industry. So starch really has good importance in the society. And we are going to begin. There are 3 important starches. Number 1, and most widely starch is a cornstarch. Number 2 is a potato starch, and third one is a tapioca starch. These are the important starches, and starches are present in many other plants, but these 3 are commercially important starches. We are going to demonstrate to you the starch separation from potato. And here we have a potato, and this is the peeled potato pieces. And what we are going to do, we are going to make it from the pulp in a mixer. Bhakti is going to do that, and thereafter we will be passing it. We are going to begin with the very first experiment, that is separation of starch from potato. Let me give some idea about the starch. Starch is extensively used in industry, whether it is food industry, pharmaceutical industry, or textile industry, or the paper industry. Starch really has good importance. Let me give some idea about the starch. And we are going to begin. There are 3 important starches. Number 1, food industry, and most widely used starch is cornstarch. Number 2 is the potato industry, and third one is the tapioca importance. These are the important starches, and we are going to begin many other important plants, but these 3 are commercially important. We are going to demonstrate to you the starch separation from the potato. And here we have a potato, and this is the peeled potato plant. And what we are going to do, we are going to make it from the pulp in a mixer. So Bhakti is going to do that, and thereafter here we have a potato, and this is the mesh which we are using. It actually is about 60 mesh, and the starch grain of the potato is about Bhakti is going to do that, and thereafter we will be passing it. We are going to begin with the very first experiment, that is separation of starch from potato. Let me give some idea about the starch industry, whether it is food industry, pharmaceutical industry, or textile industry, or paper industry. So starch really has good importance in the society. And we are going to begin. There are 3 important starches. We are going to begin with starch from potato. Let me paper industry, and third one is that is good importance here in the society, and we are going to begin many other important plant.
Hello.
We are going to
Just keep
demonstrate you. We are going to begin with the very first experiment.
We are checking the audio. Just see it.
We are going to begin with the very first experiment, that is separation of starch from potato. Let me give some idea about the starch. Starch is extensively used in industry, whether it is food industry, pharmaceutical industry, or textile industry, or the paper industry. Let me give some idea about the starch. Starch is extensively used in industry, whether it is food industry, pharmaceutical industry, or
which is group 1? Here, from the right we'll start. Group 1. Just prepare answer for these questions. Prepare 7 major sources of starch. Okay, you sit and discuss among, each of you can do, or together as a group, you can choose a representative. All of you do the same. For one I'll give one question, so you will get the best out of what is happening. 7 different sources of starch, and chemically what is starch? What are the 2 chains? The alpha 1,4 linkage is between what? 1,6 linkage is between what? So you have to know that. Next, second group at the back. What is embellin? Second group, raise your hands. Group 2. This is 1, no? You are 2. Okay, embellin. What is embellin chemically? Okay. So this is second. That is second group. What is embellin chemically? What is embellia ribes in Marathi? These are the questions you have to prepare the answer for. Which other molecule comes very close to embellin structurally? Any natural molecule. These 3 questions you have to prepare. Prepare the answers for that. Next group, third. Of course, you know quinine. Along with quinine, what are the other alkaloids which are present in cinchona bark? 30 different alkaloids are present, you know that. So besides quinine, first thing is quinine, what is it structurally? Structurally, what is quinine? What are the 4 major species of cinchona from which it is isolated? And what other alkaloids are present along with quinine in cinchona? When he is doing the isolation, you will know why he told this question. Next group, where is the next group? Yeah, caffeine. Chemical nature of caffeine, and give 2 other molecules which are very similar in structure to caffeine. You know it by heart, now itself you can tell. What are the other 2? Like caffeine? You have to Google it, I thought you know it by heart. Anyway, like caffeine, 2 other molecules were exactly structurally similar. With just one functional group alone, replacement is different. What are they? And sources of caffeine. How much of caffeine is present in tea and coffee? So which is a better devil, you must tell. These 3 questions you have to prepare the answers. Okay, next. What is nutmeg? You have to tell in English, Hindi, Marathi, Tamil and Telugu. In these 5 languages you have to tell me what is nutmeg called. Nutmeg, N-U-T-M-E-G, nutmeg's vernacular name in 5 languages, Hindi, Marathi, Tamil, Telugu, one more I told? English also, what is the common name? Nutmeg has another name. And then trimethylene, what is the chemical nature of trimethylene? By the time Ladda sir's video comes, you should have the answer, so you will be able to make better use of that. Then, what is the pharmacology of trimethylene? Trimethylene's pharmacology, what effect it has on the human system? So, answers to this. The next one is, you must know how is column chromatography different from thin layer chromatography? What is the principle, basic principle? How it is different, you must tell. And he will show you a mixture of dyes, they are getting separated. How they are getting separated. So you have to find out the meaning of theoretical plates. What are theoretical plates in column chromatography? So these 3 questions you prepare and keep it ready. Finish, that's all. Let them prepare by the time the video starts. Others, please keep quiet.
So, dear, Vande. Hello, hello,
We are going to begin with the very first experiment, that
hello.
is separation of starch
So,
from
dear
potato.
participants, we'll
Let me
play
give some
the
idea
video
about
of
the
our
starch
first
that is
particle,
extensively
which
used in
is
the industry,
isolation of
whether
starch
it is food
from
industry, pharmaceutical industry, or textile industry, or the paper industry. So
explanation of the
starch really
practical will
has
be
good
given afterwards.
importance
We'll
in the
just play
society,
the
and we are going
video.
to begin. There are
So,
three important
technical team,
starches.
please
Number
roll the
one,
video.
and most widely used starch is a cornstarch. Number two is a potato starch, and third one is a tapioca starch. So they are the important starches, and starches are present in many other plant, but these three are commercially important starches. We are going to demonstrate to you a starch separation in many other plant. We are going to begin with the very first experiment, that is separation of starch from potato. Let me give some idea about the starch. We are going to begin with the very first experiment, whether it is food industry, pharmaceutical industry, or textile industry. Some idea about the starch. We are going to begin with the very first experiment. We are going to begin with the very first experiment, that is separation of starch from potato. Some idea about the starch. We are going to begin with the very first experiment. We are begin with the very first experiment, that is separation of starch from potato. Some idea about the starch. We are going to begin with the very first experiment. We are begin with the very first experiment, that is separation of starch from potato. Some idea about the starch. We are going to begin with the very first experiment. We are begin with the very first experiment, that is separation of starch from potato. Some idea about the starch. We are going to begin with the very first experiment. We are begin with the very first experiment, that is separation of starch from potato. Some idea about the starch. We are going to begin with the very first experiment. We are begin with the very first experiment, that is separation of starch from potato. Some idea about the starch. We are going to begin with the very first experiment. We are begin with the very first experiment, that is separation of starch from potato. Some idea about the starch. We are going to begin with the very first experiment. We are begin with the very first experiment, that is separation of starch from potato. Some idea about the starch. We are going to begin with the very first experiment. We are begin with the very first experiment, that is separation of starch from potato. Some idea about the starch. We are going to begin with the very first experiment. We are begin with the very first experiment, that is separation of starch from potato. Some idea about the starch. We are going to begin with the very first experiment, that is separation of starch from potato. Let me give some idea about separation of starch from potato. Let me give some idea about the starch potato. Let me give some idea about whether it is food industry, pharmaceutical industry, or textile industry, or the paper industry. So starch really has good importance in the society, and we are going to begin. There are three important starches: paper industry, number two is the potato starch, and we are going to begin. Third one is the tapioca starch. So these are the important starches, and starches are present in many other number two is the potato starch, and we are going to begin. Third one is the tapioca starch. So these are the important starches, and starches are present in many other number two is the potato starch, and we are going to begin. Third one is the tapioca starch. So these are the important starches, and starches are present in many other number two is the potato starch, and we are going to begin. Third one is the tapioca starch. So these are the important starches, and starches are present in many other number two is the potato starch, and we are going to begin. Third one is the tapioca starch. We are going to begin with the very first experiment, that is separation of starch from potato. Let me give some idea about the starch. Starch is extensively used in the industry, whether it is food industry, pharmaceutical industry, or textile industry, or the paper industry. So starch really has good importance in the society, and we are going to begin. There are three important starches. Number one, and most widely used starch, is a cornstarch. Number two is a potato starch. We are going to begin with the very first experiment, that is separation of starch from potato. Let me give some idea about the starch. Starch is extensively used in the industry, whether it is food industry, pharmaceutical industry, or textile industry, or the paper industry. So starch really has good importance in the society, and we are going to begin. There are three important starches. Number one, and most widely used starch is a cornstarch. Number 2 is a potato starch, and third one is a tapioca starch. So they are the important starches, and starches are present in many other plant, but these three are commercially important starches. We are going to demonstrate you the starch separation from potato. And here we have a potato, and this is the peeled potato pieces. And what we are going to do, we are going to begin with the very first experiment, that is separation of starch from potato. Let me give some idea about the starch. Starch is extensively used in the industry, whether it is food industry, pharmaceutical industry, or textile industry, or the paper industry. So starch really has good importance in the society. And we are going to begin. There are three important starches. Number 1, and most widely used starch, is a cornstarch. Number 2 is a potato starch. We are going to begin with the very first experiment, that is separation of starch from potato. Let me give some idea about the starch. Starch is extensively used in the industry, whether it is food industry, pharmaceutical industry, or textile industry, or the paper industry. So starch really has good importance in the society. And we are going to begin. There are three important starches. Number 1, and most widely used starch, is a cornstarch. Number 2 is a potato starch, and third one is a tapioca starch. So they are the important starches, and starches are present in many other plant, but these three are commercially important starches. We are going to demonstrate you the starch separation from potato. And here we have a potato. We are going to begin with the very first experiment, that is separation of starch from potato. Let me give some idea about the starch. Starch is extensively used in the industry, whether it is food industry, pharmaceutical industry, or textile industry, or the paper industry. So starch really has good importance in the society. And we are going to begin. There are three important starches. Number 1, and most widely used starch, is a cornstarch. Number 2 is a potato starch, and third one is a tapioca starch. So they are the important starches, and starches are present in many other plant, but these three are commercially important starches. We are going to demonstrate you the starch separation from potato. And here we have a potato, and this is the peeled potato pieces. And what we are going to do, we are going to make it from the pulp in a mixer. Bhakti is going to do that, and thereafter we'll be passing it through the mesh. Now the mesh which we are using it actually is about 60 mesh, and the starch grain of the potato is about up to 100 micron in diameter, and so it will pass through it actually, whereas the cellulosic material which remains behind, potato contains around 17% of a starch. Okay, and so we are going to pass it through the mesh. Whatever get passed through that will be the starch. Then we'll pass it in the beaker. We will allow the starch to settle down, which is a heavier, and supernatant will decant it, and thereafter we will give the washing actually, just one more washing with the water, and thereafter we will try to dry it actually along with the solvent. Though commercially this particular method is not used, but for the demonstration purpose we are going to use methanol for the drying purpose to remove the remaining water from that. So Bhakti, please start with it. We have a peeled potato pieces, put it in a mixer. And what we will do, once we have the starch, then we will identify that starch both chemically as well as microscopically. Okay, so now what we are going to do, we are going to make a pulp out of it, pass it through it, do it fast. Yes, add more water. Yeah, make sure you put pass it through it, do it fast. Yes. Add more water. The hand, should not. Yeah, go ahead. Yeah, make sure you put. Do it, pass it through it, do it fast. Add more water. The hand, should not. Yeah, go ahead. Fine. Yeah, make sure you pass it here. Put it immediately, instant. Okay, so now you can see here. Now we have put little citric acid because potato contains enzyme peroxidase, and if you don't put citric acid, it will start becoming brown. So it is important if you want to have a absolutely white starch, you need to put slight amount of citric acid in the cut pieces. Okay, we have passed through this. Now you can see here the starch, which we are going to transfer it in a beaker. Okay, more. Put it, don't be. Wait a minute, wait a minute, wait a minute. Take this as well. No, take this as well. Chop. It's okay, it's okay. Put it. Okay. Put it in this. We'll discard this now. Discard it. Done. So now you can see here, starch will settle down. Supernatant will discard it and will replace it. We'll give one more washing with the water. Yeah, I can see here the starch which is getting settled here. Fine? Okay. Of starch, at the base you can see the layer of the potato starch which has been settled. So Ankita, what you do? Decant the supernatant. Decant it. Completely, don't bother. Decant it. Quick. Fine? Okay. Of starch, at the base you can see the layer of the potato starch which has been settled. So Ankita, what you do? Decant the supernatant. Decant it. Completely get rid of the water. Don't bother. Decant it. Quick. Fine? Okay. Enough. Okay. So starch. Add more water. At the base you can see the layer of the potato starch which has been settled. So Ankita, what you do? Decant the supernatant. Give one more washing with water. Completely get rid of the water. Don't bother. Decant it. Quick. Fine? Okay. Okay. Enough. Okay. Okay. Now starch. Add more water. At the base you can see the layer of the potato water. Now we have put more water. We will allow the starch to settle down. Some cellulosic matter is still there that will float on the surface and that will discard it. And we'll get the pure starch at the base. In meantime, prepare for the filter. We are going to begin with the very first experiment, that is separation of starch from potato. Let me give some idea about the starch. Starch is extensively used in the industry, whether it is food industry, pharmaceutical industry, or textile industry, or the paper industry. So starch really has good importance in the society. And we are going to begin. There are three important starches. Number one, and most widely used starch, is a corn starch. Number two is a potato starch. All right. So we are going to start with the extraction and isolation of the embellin. Embellin is benzoquinone, which is present in a plant called Embellia ripes fruit or Embellia geremcotam. These are the two species which are being traded actually and which are available in the market, and that contains around 1 to 2% of the embellin. All right. So we are going to start with the extraction and isolation of the embellin. Embellin is benzoquinone, which is present in a plant called Embellia ripes fruit or Embellia geremcotam. These are the two species which are
Laboratories, Mumbai, and former faculty member of the Institute of Chemical Technology, Mumbai. Professor Ladda sir is a well-known expert in natural product research and pharmacognosy with rich experience in phytochemical isolation, extraction method, and process development. It is a special privilege for us that along with his keynote lecture, he will also conduct a hands-on isolation workshop in our college laboratory. Participants will get a rare chance to see advanced isolation techniques demonstrated live at the lab bench. Learning directly from such an expert makes today's session truly special and memorable for all of us. Thank you. Let's move towards the further session. Participants will get a rare chance to see advanced isolation techniques demonstrated live at the lab bench. Learning directly from such an expert makes today's session truly special and memorable for all of us. Thank you. Let's move towards the further session.
Hello, hello, check. Hello, 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 check. Hello,
hello. Yeah. Hello. We are going to begin with the very first experiment, that is. Yeah, please. We are going to begin with the very first experiment, that is separation of starch from potato. Let me give some idea about the starch. Starch is extensively used in the industry, whether it is food industry, pharmaceutical industry, or textile industry, or the paper industry. So starch really has good importance in the so, let me give some idea about the starch. Starch is extensively used in the industry, whether it is food industry, pharmaceutical industry, or textile industry or the paper industry. So starch really has good importance in the society. And we are going to begin. There are three important starches. Number one, and most widely used starch is a cornstarch. Number two is a potato starch. And third one is a tapioca starch. So these are the important starches, and starches are present in many other plant, but these three are commercially important starches. We are going to demonstrate you the starch separation from potato. And here we have a potato, and this is the peeled potato pieces. And what we are going to do, we are separation from potato. And here we have a potato, and this is the peeled potato pieces. And what we are going to do, we are
No, you stop the audio. I will explain that. You run the video only. Only video. Okay?
going to make it from the pulp in a mixer. Bhakti is going to do that, and thereafter we'll be passing it through the mesh. Now the mesh which we are using it actually is about 60 mesh, and the starch grain of the potato is about up to 100 micron in diameter, and so it will pass through it actually, whereas the cellulosic material which remains behind, potato contains around 17% of a starch. Okay, and so we are going to pass it through the mesh. Whatever get passed through that will be the starch. Then we'll pass it in the beaker. We will allow the starch to settle down, which is a heavier, and supernatant will decant it, and thereafter we will give the washing actually. Just one more washing with the water, and thereafter we will try to dry it actually along with the solvent. Though commercially this particular method is not used, but for the demonstration purpose we are going to use methanol for the drying purpose to remove the remaining water from that. So Bhakti, please start with it. We have a peeled potato pieces, put it in a mixer. And what we will do, once we have the starch, then we will identify that starch both chemically as well as microscopically.
The starch which is present in that gets separated from the cellular structure.
Okay, so now what we are going to do, we are going to make a pulp out of it, pass it through it, do it fast. Add more water.
By which all the starch grains which are present in the potato get passed on.
Yeah, make sure you put the hand, it should not. Yeah, go ahead. Do it more.
And the cellulose matter retains on the
Fine. Pass it here.
I am sure all
Put
of
it
you are
immediately.
enjoying.
Instant. Okay. So now you can see here.
Correct, no? Anybody knows that it contains starch?
Now we have put little citric acid because potato contains enzyme peroxidase, and if you don't put citric acid, it will start becoming brown. So it is important, if you want to have a absolutely white starch, you need to put slight amount of citric acid in the cut pieces. Okay, we have passed through this. Now you can see here the starch, which we are going to transfer it in a beaker. Okay, more.
So which will be put into the.
Put it, don't be.
So you can see now the starch suspension.
Wait a minute.
Here at the summit you will find the starch which is getting set.
Take this as well. No, take this as well.
And thereafter the starch is given further washing with the water. Now you need to also take contains good amount of
Okay, put it.
before
Put this.
do add some amount of acid in that. Normally citric acid is the one which is been used so that it doesn't lead to the browning of the starch. Otherwise you will get the starch not white but the brown color starch. Okay, so now you can see
We will discard this now.
which is being put here, and the starch will slowly get deposited at the base.
Discard it.
It is heavier than water, and it will form the lower layer in the beaker.
Done. So now you can see here, starch will settle down. Supernatant will discard it and will replace it. Will give one more washing with the water.
Is amylose, and the second one is
Yeah.
amylopectin. Amylose gives
We are going to begin with the very first experiment, that is separation of starch from potato.
together
Let me give some idea about the starch. Starch is extensively used in the industry, whether it is food industry, pharmaceutical industry, or textile industry, or the paper industry. So starch really has good importance in the society. And we are going to begin. There are three important starches. Number one, and most widely used starch is a cornstarch. Number two is a potato starch, and third one is a tapioca starch. So these are the important starches, and starches are present in many other plant, but these three are commercially important starches. We are going to demonstrate you the starch separation from potato. And here we have a potato, and this is the peeled potato pieces.
All potato from the US is only containing amylopectin, not
We are going to begin with the very first experiment,
pink color
that
when
is
you
separation of
see
starch
the
from potato. Let me give some idea about the starch. Starch is extensively used in the industry, whether it is food industry, pharmaceutical industry, or textile industry, or the paper industry. So starch really has good importance in the society. And we are going to begin. There are three important starches. Number one, and most widely used starch is a cornstarch. Number two is a potato starch, and third one is a tapioca starch. So these are the important starches, and starches are present in many other plant, but these three are commercially important starches. We are going to demonstrate you the starch separation from potato. And here we have a potato, and this is the peeled potato pieces. And what we are going to do, we are going to make it from the pulp in a mixer. Bhakti is going to do that. We are going to begin with the way from the pulp in a mixer. Bhakti is going to do that. This is called the fluted filter paper, and the entire area is now available for the filtration. Okay, all right. This has started. In meantime, we'll simply check it with the test tube, whether whatever we got it, whether it is having the.
acid drying, we have to take it with the alcohol. Normally one should not do, industry do not do this. Industry they take it actually first the centrifugation and thereafter the flash drying. But in this particular case, since we
Now
wanted
this
to
is a
check
starch
how we
suspension.
filter that off,
In this you
use
put
the
iodine and
sugar
see whether the color
before we
changes.
take away the water along with it.
Do you have a dropper, or otherwise you can? Okay.
We can test which is running it. So she is putting suspension and then iodine solution.
Yes, it has become purple.
Starch, it will become actually purple in color.
Yeah. So now you can see actually it has become purple.
Whatever we separate,
Why it has become purple? I'll tell you. The starch comprises of the two components, amylose and the amylopectin. Amylose is a linear polymer. Amylopectin is a branch chain.
but yes, it was
Amylose gives intense blue color,
microscopic.
and amylopectin gives pink color with iodine.
Get the microscopic image.
Intense blue color, and amylopectin gives pink color with iodine.
Yeah. Yeah. Here is a microscopic image, and you can see in the microscope
All right.
only the starch
So,
grains of the potato. Okay, oblong in size. Sorry, what happened?
all right. So,
Okay, starch has certain features. One is hilum, which is a starting point, and thereafter it has, particularly potato starch, had lot of concentric rings, which denotes its subsequent development. Okay, yeah. So you can see the oblong is a shape, and hilum is normally eccentric. That means it is not in the center. It is eccentric. Okay, and of course striations or the circular rings are not very clear, but those were clear in the microscope. Okay, all right. So that was the first assessment about the separation of the starch. You can also separate starch from the wheat. Cornstarch is very important, very, I mean, commercial, and it is largely been undertaken on a very big scale. Wheat starch has a problem actually that it contains good amount of gluten. So wheat starch separation needs first soaking of a purified wheat flour, and thereafter actually after almost half an hour you need to constantly treat with the jet of the water wherein the starch gets separated and the gluten, which is a elastic mass, remains behind. So there is a separation of wheat starch as well. Next experiment.
we are going to begin with. All right. So, we are going to begin with.
No, I think you're going back.
All right. So,
Okay, this was about embellin.
All right. So we are going to start with the extraction and isolation of the embellin. Embellin is benzoquinone, which is present in a plant called Embellia ripes fruit or Embellia geremcotam. These are the two species which are being traded actually and which are available in the market, and that contains around 1 to 2% of the embellin. And embellin is a benzoquinone. All quinones are colored
This is
compound,
about
whether it is a
separation
benzoquinone,
of
naphthaquinone, or the
embellin from
anthraquinone.
embellia ripes.
And
Embellin
this is the powder actually of Embellia ripes, and Embellia ripes is normally been used in the traditional system, or other I'll put it folklore. Normally when the water is given to the infant, normally there is a practice that we add
Okay,
4 to 5 fruit
benzoquinone
actually in the water, boil it, and then
which
that
is
water is normally being fed to the
in
infant.
action.
It's a practice.
Now,
In
this water
vernacular,
demonstration is
Embellia
pertain to the
is known
separation
by
of
the word
embellin
called
from
vidang or
embellia ripes
vowding.
fruit,
Okay,
and the method which was
and we are going
used
to
is
do extraction and isolation
extracted
of the
the
embellin.
powdered embellia ripes fruit with petroleum ether after extraction. Now, embellin as such is not soluble in petroleum ether, but still we are used for the extraction petroleum ether. The reason being because embellia ripe fruit contains seed inside, seed has lipid inside, and lipid is soluble in pet ether. Embellin is soluble in lipid, and lipid in turn is soluble in pet ether, and that is why though embellin is not soluble in pet ether, but still we are use pet ether as a extracting solvent in
All
which
right.
both lipid
So
as well as embellin got
we are
extracted.
going to start with the extraction and
And we took
isolation of the
advantage
embellin.
of the separation
Embellin is
property of
benzoquinone, which is
embellin that
present
it
in
is
a
not
plant called Embellia ripes
soluble
fruit
in petroleum
or
ether.
Embellia
So
geremcotam. These are
separation
the two species which
the
are
stage
being
comes
traded actually and
when
which are
the
available in the
solvent
market,
is less
and that
and two
contains around 1 to
candidate are
2% of the
fighting for
embellin.
dissolution.
And
And
embellin is a
embellin being
benzoquinone.
less soluble will
All
absorb
quinones are colored compound,
and
whether it is a
lipid being more
benzoquinone,
soluble will
naphthaquinone, or the
remain inside
anthraquinone.
the pet ether
And
solvent. So after
these
extraction
are
of embellin
this is the powder actually of Embellia ripes,
embellin will
and
get
Embellia
separated in the
ripes
form of
is
reciprocate,
normally been
whereas
used in the
this
traditional
part
system,
which is present
or
inside
other I'll
get
put it
absorbed into the
folklore. Normally when the water is
and then on
given to the
filtration you will
infant,
get
normally there is a practice that
embellin
we add
which is
4 to
extracted
5
and
fruit
then
actually in the water, boil it, and then that
purified
water is
by
normally being
dissolving
fed to the
into the
infant.
methanol
It's a practice.
and thereby
In vernacular,
oxidizing this.
Embellia
So this is
is known
precisely
by
the
the word
extraction
called
of the
vidang or
polycarbonate
vowding.
oxide.
Okay,
So this is
and
the
we are going
solvent
to
apparatus
do extraction and
which
isolation
requires
of the
both the
embellin from
instrument
Embellia
powder.
ripes fruit powder.
As long as you have
Before
both
that, we will
works, you
ascertain
need not
whether
to
the
uncouple.
embellin is present in a powder
Simple
or not.
problem actually.
Here,
The
we have a
area
standard
what
embellin
you get is
which
very
is
less.
obtained,
So
and we are
instead
going
of
to make
using full
solution in
cotton,
methanol,
because in most
against
powders
which we will confirm
embellin
whether our
later on
powder
undergoes
has
filtration
embellin
process
content
which
in it or
actually
not.
very
So this is a
small
standard
amount
embellin.
do pass through
Now
the
we are ready with a
cylinder
solution in
through standard
methanol. So
operation
this is a standard
requires
embellin. Just
filtration.
shake
We need
it
not
so that
bother
it will
about
be
that.
and we are going
And
to
this
do
was
get
what
the
we are trying to
test tube.
do. Whenever you undertake extraction isolation, the first and foremost important thing is that you must confirm the raw material which you have purchased
And
or
this
which you are
powder also we are going to extract with
okay,
methanol,
and that is possible
and then
by
we will test it with the TLC.
doing actually either chemical test or by the thin film chromatography. So here what we are trying to do, we are trying
Can
to
we have
use the
little
thin
heating
film
arrangement?
chromatography to see whether embellin is present in the raw material which we are going to
Okay,
separate
this
for
is
the
done.
extraction.
So now we have a
So what
standard
we did, we had
and we have a
a pure embellin against which we took the extract, 1 gram of embellia powder
okay.
to which added
So
methanol,
standard and the
and
test
that
is ready.
extract
So
was
what we are going to
used
do,
for the
we are going to
development of
first
the TLC. So
ascertain
here 1 gram
on
powder
TLC
is
plate,
added along with the treated with the methanol, heated. So now our sample is
or
ready,
we will be
and
putting the
now it
two
is
track,
open for the
one
TLC.
of the standard and the one of the
And
test,
once you get
and then we'll
corresponding
run it in the
spot in the
solvent
TLC, that
system.
is the indication that yes, your raw material has embellin in it, and that is what precisely we
On
did.
the left hand, I will be on the left side, I will be putting the
Demonstration of
standard
TLC.
track
So you
of
can
my left
see
side. And on the right, I will be putting the methanol extract of
this was the
our
bottle
sample from which we are going to do
methanol
the
extract, so you
extraction.
need not take every time new capillary. Same capillary you can reuse it actually after washing.
Okay. So now spotting has been done. We have done the spotting actually, leaving 5 mm from the base. Here is the solvent system which comprises of N-propanol, butanol, and ammonia, which we are going to use it for the developing
Yes,
TLC
you
plate.
get the two bands for the development. One on the left side,
What you need is only 2 to 3
and
ml.
on the
That
right side, the extract which is made actually of the embellia ripes fruit. and then it
What
was
you
run
need is only 2 to 3 ml. That
with the solvent system. Normally, you need only 2 to 3 ml solvent for running TLC plate. Don't make more than that. At the most, 2
all
ml
right.
solvent is more than
So
important, more than sufficient.
we are going to start with the extraction and isolation of the embellin. Embellin is benzoquinone, which is present in a plant called Embellia ripes fruit or Embellia geremcotam. These are the two species which are being traded actually and which are available in the market. More time, and once the extraction is complete, then we'll do the further processing.
So now you can see here
What is better?
the
No?
succinate powder has been put here, and now the succinate will be run. In meantime,
I
TLC
can come
which
closer
is
and see.
developed is ready now.
And
Again, not very clear, I'm sorry, but there were two, yeah, you can see the spot here and corresponding spot here. Yeah, you can see the spot here and corresponding spot here. What happened?
all right. So we are going to start with the extraction and isolation of the embellin. Embellin. All
No
right.
problem.
So we are going to start with the extraction and isolation of the embellin. Embellin. All right. So we are going to start with the extraction and isolation of the embellin. Embellin.
Huh. Aside, huh? Okay.
Experiment. Separation of quinine from cinchona bark. Here we have a cinchona powder and all the other things which are related, which are required for the separation. I'll tell you in brief what is the procedure. Now, cinchona bark contains cinchona alkaloid. There are four alkaloids: quinine, quinidine, cinchonium, cinchonidine, of which quinine is the most important and which is being used as an antimalarial drug. And it is also standard beater. Now, in plant, it is present in the form of a salt, and those are normally hydrophilic. So what we are going to do, we are going to treat this with a alkali. So here I have a calcium hydroxide, which is alkali. So what we will do, we will impregnate this powder with the calcium hydroxide, and then we will have to keep it for half an hour, so that this calcium hydroxide should go into the cell.
Okay, I think there's some problem with the audio. So what I will do, I will explain you. This is extraction and isolation of quinine from cinchona bark. And cinchona bark contains quinine as an alkaloid. And method of the alkaloid separation is very simple. Depending upon the composition of a material, there are two methods. One is either you treat initially with the alkali and then extract with the organic solvent, or alternatively you first extract with the acid related solvent and then extract with the organic solvent. Okay, so in this case what we have followed actually is treated with alkali. So this is what calcium hydroxide, and cinchona bark powder is been taken. It is treated with the calcium hydroxide and it is kept for half an hour so that it should get imbibed. And because whenever you undertake powdering, in the powdering process you are only damaging the tissue cells remain intact, and that is why extraction normally takes pretty long time. The reason being because solvent has to get into the cell, dissolve the analyte, and then come out of the cell, and this whole process takes longer period. And with the result, in this particular case, we have to soak it for half an hour. So after treating with alkali, we kept it for the half an hour for the soaking, and afterwards, once you soak it in with alkali or when you treat with alkali, the alkaloid which is present in the plant in the form of a salt gets converted into a free base. And once it gets converted into a free base, then it becomes more lipophilic. Initially, when it is present in the plant, it is in a hydrophilic form. But when you treat with alkali, it gets converted into a lipophilic form. Once it gets converted to a lipophilic form, thereafter we have to extract with the solvent which is non-polar. So in this particular case, we use solvent toluene as a solvent. Toluene is having the advantage that it is boiling point of the toluene is 110 degree. Industry prefer to use this solvent rather than low boiling solvent because in industry they normally undertake recovery, and high boiling solvent are easy to recover as compared to low boiling solvent which has lot of losses. Okay, so in this particular case, now what is going on here, we are trying to demonstrate that again, as I told you, whenever you undertake extraction isolation, first confirm that raw material which you have bought contains the desired constituent in it. Most important thing. Without that, do not proceed. So here what we are trying to do, we are actually trying to ascertain the powder which is there contains quinine in it with the help of TLC. So the TLC has been run using chloroform and diethanolamine as a triethanolamine as a system. This is a solvent system. Again, we have compared with the standard. So TLC is getting developed. You need not run very, you can manage with just 6 centimeter plate. You need not run 8 to 10 centimeter unnecessary and waste time. Okay, now the TLC has been put up here. Fast forward little. So we need not waste. So here it was the extract. TLC is getting developed. Here we are trying to show you the chemical test. So you can see here 2 test tubes. One you can see the blue fluorescent. That is a chemical test. That was the extract which was treated with the sulfuric acid. In another tube, it was only water, and here in this case, water plus extract plus sulfuric acid. Here it is only water and sulfuric acid. And you can see here the blue fluorescence. This is the reflection of the glass, but here in this case, you can see uniformly blue fluorescence. Same thing we will show it to you in UV lamp as well. Fast forward. Yeah, now you can see in the UV. Okay, fellow is taking a photograph. Yes, so you can see the blue fluorescence, and here there is no fluorescence. Yeah, blue fluorescence, and there is no fluorescence in this particular tube, which is a indication that yes, our sample do contain quinine in it. Okay, TLC plate now they are removing. Now TLC plate is treated with sulfuric acid in methanol, and then on exposure to the UV, you will be able to see. Yeah, you can see now the spot. Okay, I think, yeah, this is on the left side. It has become too bright. No. Yeah, this is standard and this is a test material. Okay, so even on the TLC, it is showing the presence of the quinine in it. Okay, then of course the extraction was continued. forward it. Yeah. Now here is, wait a minute, just go back. Yeah, here you can see now clearly. So this is standard and this is the extract. So it is showing corresponding spot of quinine in the extract as well. So now this is cinchona powder. Alkali has been put into that. Triturated. You have to make sure that all particles, entire powder gets impregnated with the alkali. Then only you will get the better yield. Yeah, you need to wear the gloves. The reason, because we are handling alkali. So be careful. You need to use as less amount of water as possible, because later on we have to treat this with organic solvent. In case if you use too much of water, then there will be a problem of the separation. And that is why you can see here it is powder which is treated with alkali in water, but at the same time it is free flowing. Okay, it's been getting transferred into a flask, and then it will be refluxed along with toluene. Okay, now it is toluene which has been put into that. Okay, now it is ready for the extraction. We have to reflux now. So it has been now subjected to the refluxation. At refluxation will occur at 110 degrees, that is at the boiling point of a toluene. Forward it. Okay, now you can see the boiling which is taking place, which is facilitating the extraction process. Now we are going to separate the organic layer, that is toluene layer, in which quinine has now come. It is very hot. Cotton has been put so that no particle should pass through that. That is the reason the cotton has been put. Toluene layer is getting separated, which contains quinine in it now. We are just confirming whether extract do contain quinine or not, again by the same test, that is fluorescent test by treating with sulfuric acid. So she is performing the test, adding sulfuric acid and then water and then exposing to the UV at 366 nanometer. And you can see the blue fluorescence. Okay, so yeah, it was quite clear. Blue fluorescence was quite clear. Very intense. So good amount of quinine has come into the extract. Okay, this is toluene layer, and you can see some particle did pass, so the cotton was worth placing it. Now we are going to, now the quinine has come in the organic layer. Now we are treating with sulfuric acid at 10%, wherein quinine will form a sulfate and it will become a part of the aqueous layer. Okay, quinine, this has been treated sulfuric acid, 10% sulfuric acid in water. So you can see the lower layer. Okay, so here you can see the layer is getting clear, it's becoming clear. And so initially when you extract it with the toluene, all hydrophilic impurities remain behind because toluene is a solvent which is lipophilic. Now it is extracted with the sulfuric acid, so all lipophilic impurities are now remaining in the toluene layer. Okay? Yeah, the layer got clear and now it will be separated. So now the quinine is present here in the form of quinine sulfate. Okay. One more portion we are using it. 2 portions of sulfuric acid. Normally acid do not pose much problem, but if you use the base, then you will get a lot of problem because it forms the emulsion. Okay. Now this is the sulfuric acid layer in which quinine is present in the form of the sulfate. And now this will be precipitated by adding sodium hydroxide. But precipitation will be undertaken only in the acidic range because quinine sulfate has less solubility around pH 6 to 7. So we are going to add drop-wise sulfuric sodium hydroxide solution till we get the persistent precipitate. Commercial pause. Huh? Okay. Yeah, sorry for the inconvenience because it was recorded in different attempts and that is why they are finding it difficult to join. Okay, this is another experiment. I'll come to it little later about the quinine part of it. There's another experiment. You can see here nutmeg, and nutmeg is actually a spice which is from the Myristica fragrance seed, and that contains important constituent called trimyristin. It's a lipid part of it. It contains almost 40 to 45% trimyristin. Okay, so what we did in this case, the nutmeg powder, nutmeg is converted into a powder first, then it is extracted with a chloroform in which it is highly soluble. But if you look at the composition of the nutmeg, nutmeg also contains volatile constituent. myristicin, elemicin, and saffrole. That also get extracted when you extract with the chloroform. And nutmeg butter, which primarily comprises of trimyristin, also get extracted. So both of them are refluxed actually, and now it has been getting filtered. So here we have a chloroform extract of nutmeg, which has trimyristin as well as other constituent, which primarily includes volatile oil. But what we want only trimyristin and not the volatile oil constituent at this moment. Are soluble. So after concentration, now this is the filtration. Afterward, this will be concentrated. After concentration, then it is treated with the acetone, and acetone dissolve all the impurities, and trimyristin, which is not soluble in the acetone, is being separated in a form of a white amorphous powder. Okay. Yeah, there was some problem, some contamination went, so refiltering. While handling chloroform, be careful, don't inhale. Trimyristin is a myristic acid, it's a triglyceride. Okay, so all the 3 hydroxy group of the glycerin is esterified with myristic acid, that is C14 acid. Okay, you can fast forward. Yes. Okay. All right, we are going to concentrate now. Since we were in hurry, we allowed it to evaporate. Okay, otherwise you should recover. Okay. All right, this is concentrated now. After concentration, we have put acetone. Okay, they are straight away. Okay, in between you have missed. Get it a little early. Yeah, acetone, now you can see the precipitate. Go a little backward. Yeah. Okay, just hold on. Yeah, you can see here the acetone has been put here. Acetone has been put along with the concentrated chloroform layer. I'm just trying to confirm whether the product is getting separated or not with the help of the torch. And yes, I could see the product. Okay. Yeah, then I have put a small quantity in a test tube, and yes, after cooling it, now you can see the separation of the product. Yeah, the product got separated here in this case in a form of the precipitate. Yeah, you can see the precipitate. Now it is getting filtered. Now you can see here powder which is formed. Done? Fine. Okay. Now, a couple of experiments are still remaining. Okay. Here is a column chromatography. So this is a green dye. Green dye, which is a mixture of tartrazine yellow and brilliant blue. Together it becomes blue dye, and we are trying to separate or demonstrate the separation of yellow and blue color by column chromatography. Using silica gel, this is a silica gel around 60 to 120 mesh, which is typically meant for the column chromatography. We are using water as a eluting solvent. Slurry has been made. Yeah, slurry in water has been made. Put into the column. No, go back. Oh, too much fast forward. Go a little ahead. This is getting repeated. Slurry has been put into the column. Water is allowed to drain. Okay. Straight away it has come? Huh? No. Come up to here, somewhere here. Throw आणखीन back. Leave it now. Okay. Yeah, I think in between thing has not come. We have put the thing green color, and now you can see here the yellow, green and blue getting separated. Okay. So yellow being it's eluted first. Thereafter in between we have a green color, and finally we have a blue color which has been separated. We collected the fraction around 2 to 3 ml. Go ahead, little. Thoda pude. Okay, so now you can see yellow, green and finally blue getting separated by the column chromatography. Done. Thank you. Next. Either you clap after every experiment. Yeah, this is separation of caffeine from tea. So you can see this is a tea powder. Caffeine is having the distinct advantage that caffeine is both hydrophilic and lipophilic. It is more soluble in hot water and less soluble in cold water. So advantage has been taken of that particular property, that it is extracted in hot water, then that water is allowed to cool, or the extract is allowed to cool, and on cooling that extract is treated with a dichloromethane, which is lipophilic solvent. So it is having less solubility in cold in water, so it has more affinity with the dichloromethane and it gets extracted with the dichloromethane. So this is what it is extracted with the hot water for 5 to 7 minutes. Filter through this bag. This bag is made up of the polypropylene. Little fast forward. Yeah, getting filtered. Yeah, tea extract. By the way, tea extract also contains EGCG, that is epigallocatechin gallate. Okay, this is the extract. Now it is treated with the dichloromethane. This is to be cooled because dichloromethane is having the boiling point of around 40 degree. So you cannot straight away, because this was extracted in the hot water, so you don't straight away put the dichloromethane, otherwise everything will splash. So allow it to cool. Yeah, this is after cooling. Now it is extracted with the dichloromethane. Dichloromethane being heavier, forming the lower layer, and caffeine now got extracted in the dichloromethane. The lower layer is being separated, which contains caffeine in it, and while I was pouring, it has, you can see on the side the caffeine got precipitated. Caffeine shows nice needle-shaped crystals under microscope, and this is what the next thing will follow here. A microscope is being arranged, and this is the dichloromethane layer. Just couple of drops are put on the slide, allow it to dry. So on drying, it has crystallized. One more portion of dichloromethane or methylene dichloride, whichever you call it. Okay. So now the crystals which are formed being observed under a microscope. Go a little fast forward. Yeah. you can see the crystals of caffeine, needle-shaped crystals of caffeine all along. So whatever we extracted, it has resulted in the formation of needle-shaped crystals in it. All right, done. Anything else? Okay, so these are all the products, potato to starch, transformation of potato to starch, tea powder to caffeine. This is nutmeg to trimyrostin. This is trimyrostin. This is cinchona bark to quinine. This is embelline. We are unable to dry, but you can see the crystals here which has been separated in a test tube. You can see the crystals. I'm sorry, go back a little. Yeah, this is the crystals which have been separated here. Okay, earlier, slightly. Yeah, that was not the part of the demonstration. Here you can see the separation of dye. So this was the green color originally used. Yellow got separated, greenish, and then of course blue. Okay, so those were some 5 to 6 experiments demonstrating separation, TLC, and column chromatography from herbal to phytochemicals. Thank you very much.
Hello. Thank you so much, sir.
Thank you.
So your session was truly very informative. So I request you to have a seat, sir.
Thank you, ma'am.
Now I request Sadhodan to declare or to give the vote of thanks. Before vote of thanks, the session and the forum is open for all the audience. If any one of you is having any kind of question, please feel free to question. The session is open for question answer sessions.
Hello.
Yes, please go ahead. Correct. Okay. Okay, I got your point. I'll give the example. Beta-cytosterol and stigmasterol.
Hello.
These differ by only with one double bond. Beta-cytosterol and stigmasterol. They differ only by one double bond, and with the result, their physicochemical properties are almost same. Almost same. Okay? One should not unnecessarily try to separate them. Okay? One should not unnecessarily try to separate them because you will not achieve. Instead, you should find out the source where either of this is rich. Like in soya, you have a stigmasterol rich. Look for a plant in which beta-cytosterol, normally in pine, beta-cytosterol is the one which is rich. So commercially, this is the solution. Academically, you can go on pursuing. But commercially, they do not waste their time, energy, and money in that. Instead, they find out the appropriate source. Most important. Okay? Does that answer your question? Thank you. Both are found together, but normally, see, it's like, I'll give the example of a menthol. Menthol is formed from the limonene in the plant. So limonene is there, thereafter, other constituents which are part of a biosynthesis. Like polygon is there, No, isopolygon is there, menthol is there, menthol is there, and menthophenols is also there. But what is more predominant? Menthol. What is more predominant is menthol. So almost in most of the plant, very rarely you will come across most of the constituents are present in the same concentration. One or two will be a predominant constituents. Okay, so one should try to separate those constituents rather than bothering about the, for example, I came across one paper in which they tried to separate eugenol from dill, which was uncalled for. Eugenol is present in the high concentration in kalau. You should try to separate from there rather than from any other source. Okay, so be practical, don't waste your time. I'll give one more example. Quercetin, I have come across many papers, the students are trying to separate quercetin. Please stop this nonsense. Quercetin can be made by one single chemical step from the rutin. And rutin is abundantly available in plant and it can be separated from the plant in very easy step. Rutin is having very low solubility in water, cold water, but high solubility in boiling water. So it is extracted with the boiling water and water is allowed to cool whereby rutin separates. And rutin, when you treat with hydrochloric acid and deflux it for half an hour, it gets converted into a quercetin. So please do not unnecessarily waste your time, energy and money in trying to separate quercetin from a plant which is present in very low concentration. Instead, straight away make it from the rutin, but by one single chemical step, that's it. And it is natural quinine, and quinine which is semi-synthesis obtained by the semi-synthetic is same in its conformational and structural features. So there is no difference in that. Thank you. Any other question? Pardon, sir? No. Your time should be effectively utilized. Effectively. Okay? And repetitive work should be stopped. That is what we do the reference work. Reference work is for what? So that you should know what is the earlier work which has been undertaken. If you also carry out the same work, then there is no point in doing the reference. Okay? All right. Any other question? Then if not, thank you once again.
Thank you, sir. On behalf of Pravara Rural College of Pharmacy, I take this.
Good evening, everybody. First, I want to make a note that someone of sir's age, comes all the way from Mumbai to Nasik and comes to us. We planned earlier a live stream session in the afternoon, but because of technical reasons, he wanted to ensure. He said no, he'll come early. He came for 4 hours. At his age, he's standing and doing the isolations. And after the video has not come out well, sometimes some places audio, again he comes and gives his voice. He didn't have lunch with us. He had lunch in the room side, something little he ate and came. See, one thing all students must learn is, first thing is, why he's able to do it like that, because he likes what he's doing. It's the biggest blessing, boon, vardhan hota hai, that your work is what you like. But someone who is doing their work cursing, oh, I have to do this, I have to make a show in front of someone, I have to prove my boss, I have to impress my husband, I have to impress my sister-in-law, like that rest of your life you are working, no, it's a curse. Don't enter into that. See, sir is able to do that because he likes what he is doing. He wants, even amongst you, one student is getting inspired, he feels good. And he doesn't care whether you get inspired or not. He knows what he's doing and he likes what he's doing. Please give him a big round of applause for his enthusiasm. Yeah, that's good. Thank you. Thank you very much, sir. Words are not enough to show the efforts that you have shown. Thank you very much. We are really looking forward to interacting with you in future also. Thank you, sir.
Thank you, ma'am. On behalf of Pravara Rural College of Pharmacy, I take this proud opportunity to propose the vote of thanks for today's highly informative and inspiring live demonstration on phytochemical isolation. We are extremely grateful to Dr. Kirti Ladda sir for dedicating his valuable time and expertise to conduct this hands-on session in our college. It was truly a privilege for all of us to learn the live demonstration on isolation of phytochemicals directly from herbal sources, which has greatly strengthened our practical understanding of pharmacognosy. During this session, Sir successfully isolated total 6 phytochemicals: starch from potato, embelline from embella ripes, quinine from cinchona, caffeine from tea powder, trimercetin from nutmeg, separation of blue and yellow-green dye color by column chromatography. This live demonstration made the concepts much clearer and more meaningful. We would like to appreciate Sir's dedication and the enthusiasm. Despite working continuously since morning, he remained energetic, patient, and fully involved throughout the session. We have not only learned the technical aspect of phytochemical isolation, but also valuable lessons on discipline, hard work, and scientific curiosity from Sir today. Once again, we extend our sincere thanks to Dr. Kirti Ladda sir for his efforts, guidance, and encouragement. Thank you, sir.
Thank you. So here we conclude today's insightful session. So notice for tomorrow. Tomorrow's session will start sharply at 9:15. Before that, at 9 you will be having breakfast, and sharp at 9:15 we'll start with our first session. And let us conclude our today's afternoon session. I request all the audience to stand for national anthem.
Sulfuric acid solution. So then it will get converted into a quinine sulfate, and the lipid impurities will remain behind actually in toluene layer. That we will carry out in a separating funnel. Okay, and thereafter we will precipitate that sulfuric acid solution which was containing of quinine sulfate with addition of the sodium hydroxide solution to the pH of around 5 to 6. There quinine sulfate will get precipitated. So we will be doing the precipitation in the acidic range itself, not in the basic range. So acidic range, it will remain in the sulfate form itself, and that will get precipitated. Dried, and if the need arises, you can even purify that. But before that, what we are going to do, we are going to ascertain whether quinine is present in a bark, and that we will be doing it actually with the help of TLC. So please come forward. So here we have a standard quinine. So add methanol into this and prepare solution of this. And we are going to prepare solution of cinchona bark.
Thank you.
That is a standard quinine, and this is cinchona bark.
So tea arrangement for all the delegates has been done. So firstly, girls will leave the hall.
Methanol. I am going to heat it to
wait a second.
facilitate.
Let all the dignitaries leave the hall, and then you leave. Tea arrangement is done outside the hall for the delegates.